Hi everyone. Today we're going to study solution of partial differential equation by separation of variables. Let the PDE or partial differential equation be in the function of z of two independent variables x and y. Assume that the required solution be z of xy equals capital X of small x times capital Y of small y, where capital X of small x is a function of x alone, and capital Y of small y is a function of y alone. Substitute these values. Second partial derivative of z with respect to x, second partial derivative of z with respect to y, then with respect to x. Second partial derivative of z with respect to y. Partial derivative of z with respect to x. Partial derivative of z with respect to y in the given equation. Separate the variables x and y on both sides of an equation. The common ratio is capital K, while x and y are independent variables. Then we can easily solve the ordinary differential equations. Capital X of small x equals capital K, and capital Y of small y equals capital K. Example 1. Find the solution of the partial differential equation. Partial derivative of z with respect to x equals 2 times partial derivative of z with respect to t by the variable separable method. The given, we copy it here. We regard this as equation 1. Let z of x t equals capital X of small x times capital T of small t be the solution of equation 1. Let this be equation 2 now. Then let us take the partial derivative of z with respect to x, and this is equal to capital T times the derivative of capital X. Now, partial derivative of z with respect to t equals capital X times derivative of capital D. Let us substitute this t times x prime and this x times t prime to equation 1. So we have now like this. T times x prime equals 2 times x t prime. Next thing to do is to divide this equation by xt. In this case, we are now to separate the variables. The equation now becomes like this. X prime over x equals 2 times t prime over t. And this equation now is equal to a constant k. Next thing to do is to separate the variables and equate each to capital K. And it becomes like this. We have x prime over x equals k, and then 2 times t prime over t equals k. On the first equation, we cross multiply the x with a k, and this kx we will transpose to the left side. So we have now x prime minus k times x equals 0. On the other equation, we will do the same. This t we will cross multiply to the k, and this kt now we will transpose to the left side. So we have 2 times t prime minus kt equals 0. The next step is we will use operators to represent the equations respectively. For the first equation, we have this d minus k multiplied by variable x equals 0. On the second equation, we have 2d minus k. The quantity is multiplied with capital T equals 0. Then we use the auxiliary equations. In the first equation here, we have m minus k equals 0. For the second equation, we have 2m minus k equals 0. Let us solve the m respectively. The first is m equals k, and the second is m equals k over 2. Take note that the m value here, that is k, is for the x variable, while the m value here, that is k over 2, that is for the t variable. That means the formula will be like this. Capital X equals c sub 1 times e raised to kx. For the second value of m, we have this capital T equals c sub 2 times e raised to k over 2 times t. Next is we're going to substitute the values of capital X and capital T in equation 2. So it becomes like this. The z equals c sub 1 times c sub 2 times e raised to kx times e raised to k over 2 times t. This is the final answer. Example 2. Solve the equation. Partial derivative of u with respect to x equals 4 times partial derivative of u with respect to y, whereas u of 0, y equals 8 times e raised to negative 3y by the method of separation of variables. The first thing to do here is to simplify our partial differential equation. Let us write the given here, and we regard this as equation 1. Next, we let u of xy equals capital X of small x times capital Y of small y be the solution of equation 1. So we regard this equation to be the equation number 2. Next is, we will take the partial derivatives respectively. So we have here partial derivative of u with respect to x equals y times x prime, and partial derivative of u with respect to y equals x times y prime. Let us substitute the corresponding values in equation 1. So the equation 1 becomes y times x prime equals 4 times x y prime. In this case, we're going to divide the equation by xy. It means we're going to separate now the variables. So the equation now becomes x prime over x equals 4 times y prime over y. And this is now equal to the constant k. Next is, we're going to separate the variables and equate each variable to k. So we have this x prime over x equals k, and 4 times y prime over y equals k. In the first equation here, we cross multiply the x with a k, and this kx we will transpose to the left side. It becomes like this. And the second equation, this y we cross multiply to the k, and the ky now we will transpose to the left. Next thing to do, we're going to use operators for the equations respectively. For the first equation, we have this d minus k. The quantity is multiplied by capital X equals 0. For the second equation, 4d minus k, and this is multiplied by the variable y equals 0. So the auxiliary equations are m minus k equals 0 and 4m minus k equals 0 respectively. Solving for m, in here the m is equal to k, in here the m is equal to k over 4. Take note again that this k value here is for the x variable, and the k over 4 value here for m is for the y variable. It means to say we're going to write the respective equations. Capital X equals c sub 1 times e raised to kx. The next equation is capital Y equals C sub 2 times E raised to K over 4 times Y. We substitute the corresponding values to equation 2. So it becomes like this. U of xy equals C sub 1 times C sub 2 times E raised to kx times E raised to K over 4 times Y. This is now equation number 3. Next thing to do, we will now consider the given condition in the problem. That is the u of 0, y equals 8 times e raised to negative 3y. This equation means the value of u is 8 times e raised to negative 3y when x equals 0. Let us substitute the corresponding values to equation number 3. So it becomes like this. 8 times e raised to negative 3y on the left side, and that is equal to c sub 1 times c sub 2 times e raised to k times 0 times the e raised to k over 4 times y. We can simplify the right side because we have here k times 0 in the exponent. So this value here becomes 1. So the equation is simplified into like this. Now look at our equation here. By corresponding values, we say that this c sub 1 and c sub 2 that is equal to the constant 8. The k over 4 is equal to the negative 3. So this 4, when we multiply with negative 3, the value of k is derived, which is negative 12. Let us substitute the corresponding values in equation 3. So we have now this u of xy equals 8 times e raised to negative 12x times e raised to negative 3y. This is now the final answer. Example 3. Find the solution for the one-dimensional wave equation. This is second partial derivative of y with respect to t equals c squared times second partial derivative of y with respect to x. Here the x is the length of the string, t is the time, and y is the displacement of the string. Let us write the given equation here, and we regard this as equation 1. Next is, we let y of xt equals capital X of small x times capital T of small t be the solution of the given equation 1. We regard this equation now to be the number 2. Then we will take the second partial derivative of y with respect to x, and this is equal to capital T times capital X double prime, and the second partial derivative of y with respect to t. This is equal to capital X times capital T double prime. Then we substitute the values to equation 1. So we have here now t double prime times x equals c squared times t times x double prime. Now we're going to separate the variables. Let us divide this equation by xt. So the new equation becomes t double prime all over t is equal to c squared times x double prime over capital X. And then let us show that this c squared be in the coefficient for the capital T in the denominator here. So it becomes like this. Now, for this ratio, we're going to equate this into a constant k. Next thing to do is to separate the variables and equate each fraction by the k. So the left fraction here becomes t double prime all over c squared times t equals k. And the second fraction is x double prime over x equals k. Look at our first fraction here. We cross multiply this c squared t to the k. So it becomes like this, and we let the right side be equal to 0. We transpose this term to the left side, so it becomes like this. Same idea we will do to the other fraction. This capital X we will cross multiply to the k, and we let the right side be equal to 0. We transpose the kx to the left, and it becomes like this. Now we will use the operators. For the first equation, it shows that d squared minus c squared k multiplied by the variable t equals 0. For the second equation, we have this d squared minus k multiplied by the variable x equals 0. Now we're going to show the auxiliary equations respectively. For the first equation, we have now this m squared minus c squared times k equals 0. For the second equation, we have m squared minus k equals 0. Now let us solve for the m respectively. In the first equation, this negative c squared k we transpose to the right. The value of m now equals plus or minus c times the square root of k. In the second equation, we show that m squared equals positive k, and when we take the square root of both sides, m equals plus or minus the square root of k. Take note that the value of m here is for the capital T, while the value of m here is for the capital X. Now, we regard this equation into equation 3, and this equation to be equation 4. Now let us show that there is case 1, and that is when the value of k is less than 0, meaning k is negative. In that case, we expect a complex roots. Since k is less than 0, we can show that k is equal to another variable that is negative n squared. If that happens, meaning the equation 3 and equation 4 becomes m equals plus or minus c times the square root of negative n squared. The equation 4 becomes m equals plus or minus the square root of negative n squared. We simplify further, so we will get the value of m respectively. For the first, we have m equals plus or minus c times n times I. It becomes imaginary. For the second m, we have plus or minus n times I. So the value of t is equal to this c sub 1 times cosine of the quantity c n t plus c sub 2 times the sine of the quantity c times n times t. Now for the other m, that is for the variable x. Capital X now equals c sub 3 times cosine of the quantity nx plus c sub 4 times sine of the quantity nx. Next thing to do is to substitute the values of t and x to equation 2. Here is our equation 2. So we have now here y equals, the value of x is now here, and the value of t is now here. This is now the answer. Now case 2 is when k is greater than 0, meaning k is positive. In that case, we're going to have real and distinct roots. It means to say, we can take k equals n squared. So, equations 3 and 4 becomes like this. For equation 3, m equals plus or minus c times the square root of n squared. For equation 4, it becomes m equals plus or minus the square root of n squared. Solving for m respectively, m here is equal to plus or minus c times n. in here is m equals plus or minus n. So we write the values for t and x respectively. For the t, we have c sub 5 times e raised to cnt plus c sub 6 times e raised to the negative of the quantity c times n times t. For the variable x, this is equal to c sub 7 times e raised to nx plus c sub 8 times e times the negative nx. Now, we substitute the values of t and x to equation 2. Our equation 2 is here. So the value of y is equal to, this is the value of the x multiplied by the value of the t. This is now our answer. Now for case 3. This time, k is equal to 0. Therefore, we expect real and equal roots. So for k equals 0, the equations 3 and 4 becomes m equals plus or minus c times the square root of 0, and equation 4 is m equals plus or minus the square root of 0. In this case, both m is equal to 0. However, let us remember that the m value here is for the t, while the value of m here is for the x. Meaning, for the t, this is equal to c sub 9 plus c sub 10 times t. And for the x, we have capital X equals c sub 11 plus c sub 12 times x. Then we substitute the corresponding values, the x and the t, to our equation 2 here. So we have y equals, this is the value for the x multiplied by the value of the t. Here we have now the answers for the cases 1, 2, and 3 respectively. I hope you learned something from this video. See you again next time.